the scientific session, and I'm happy to ask Dr. Korchagin to speak about the properties of the galaxy disks.
But I had a brief remark. So my talk opens this, but I will try to convince you that the thick disks is an interesting topic, and it poses a lot of questions about the origin of the galaxy. And this is sort of a review talk with grabs of our own results. And the studies have been done in collaboration with my American, Chilean, and Venezuelan colleagues, and my collaborator, one of collaborators, Caterina Beers, she's in this hall, and I'm very thankful to help me to finalize, to finish that presentation just before. It is a well-known picture from two mass studies. I would say that this is the modern realization of star counts. The star counts play, a special role in studying the structure of our galaxy, going back to William Herschel's first picture of our own galaxy. So this is the modern picture. And it's well known, so we have a boxy bulge and we have the thin disk. But this is not all the story. In fact, star counts, I'll talk a little bit later, find that the flat component of our galaxy, it doesn't consist only one component. And there is another more rarefied component which is called thick disk. And the properties of that disk are quite interesting. The thick disk was discovered, as I mentioned, by star counts by Gilmark and Reed in 1983. And they clearly showed that the thick disk is a separate component which can be distinguished from the thin disk by the vertical scale height. They found that the vertical scale height of the thick disk is about 1.3 kiloparsec. And of course, it happens usually if someone finds an interesting object, people jump on that and start to study. So later redeterminations of the properties have been done by quite a few groups, and all of them really confirmed that thick disk is a real thing, believe me or not, and with more or less agreeing parameters for that disk. They show the metallicity gradient and the metallicity of overall disk and others. They find the scale compared to the thin disk. Of course, it can right velocity Yochin and Dalton selected from number three that we had the broad gaseous disk, and his idea was simple. You start with the Poisson equation, and these are forces. That's why the derivative is force. So in here, the density, of course, the gravity is determined by the total density of gravitating matter. Means visible plus double. So this is one thing. Another thing is that suppose you select a group of stars, and some group of stars which is astronomically complete, and you then can consider that group of stars as a fluid, right? And the dynamics of that fluid is determined by its own, say, pressure, gradients, and also is determined by the total potential. That's why if you measure carefully the properties, the kinematical properties of some sample of stars, that will help you to determine the potential and through this equation the total density distribution in the region. So that was Orr's idea, was exploited quite a few times. describe you one of such attempts. It's paper of Gerard et al. Published in 2006. Why this paper? Because I was one of co-authors. That's why I know something of the kilopascals. And we, astronomers in Chile, undertook a huge effort in measuring the radial velocities of the stars in that code I showed you before. So out of 1,200 red giants in the 15 dB code, they managed to measure the velocities of 824 stars. And they used also proper motions from STM3 Southern Proper Motion Catalog. And what they did, based on that remark I made before, so to be absolutely at the safe end, so they selected the stars below or above, 2 kiloparsec from the galactic midplane to exclude completely the contamination from the faintest stars. So here are the measurements in the beams, the velocity UVW, WVU velocity dispersions, they are growing as a function of Z. So this is cross correlation term that they measure. And what happens from kinematical studies of Bedin and others, the surface density accumulation between, say, 2 and 4 kiloparsecs does not agree with the overwhelming, I would say, amount of dark matter in the thick disk. There might exist some dark matter, but not that much. I don't know if it is good news or bad, but maybe it tells something about the origin of the thick disk or about the dark matter itself. Here are the parameters. So, of the formation of the thick disk might happen. So, there is a study also